Welcome back to the Space Shuttle Flight Control Room, where we have another guest here to tell us a little bit about their job here in the Mission Control Center. And this time we've got Ewan Reid, who is actually here for the mission from Canada, working with the laser camera systems that's in the orbiter boom sensor system. So he will tell us a little bit about that.
That's right, Brandy. I'm part of the LCS team. The LCS laser camera system is one of the sensors that's on the OBSS, the orbiter boom sensor system.
It's always fun to say.
Exactly. The boom is 60-foot long. It's almost a stationary robot arm that the RMS, the remote manipulator system, grapples while the shuttle's in orbit, and they use this to be able to detect and quantify damage that may have been sustained during liftoff on the shuttle's underbelly and wing leading edges.
And it uses lasers to do that?
That's right. The LCS is it's a laser rangefinder, I guess, and what it does is it can scan in two dimensions. It has galvanometers that small motors that scan in two directions, and what it does is it measures the response, the feedback from this laser, and it can then develop a model, a full three-dimensional model. So it's like taking a picture in 3 dimensions. So then once we get this data back, we can use it to, for instance, very accurately measure the volume of a damage site on the shuttle.
And this was something that was started, I guess, after the Columbia accident. The orbiter boom sensor system was added to the tools that the shuttles take up.
That's right. So there's a whole suite of sensors on the end of the boom, and a different sensor, the LDRI, is used for the majority of the initial survey of the whole TPS, the thermal protection system. And if they find an AOI, an area of interest, that is something that they think might be a pretty serious damage site, then they'll go in and do what they call a focused inspection with our system. And we'll downlink the data, and then our team here will do the analysis on the data and come up with, like I said, an accurate volume measurement. We'll pass that on to the TPS engineers, who will then make a determination about whether or not the shuttle needs some kind of repair prior to being able to withstand reentry.
So, okay, I guess we've got 2 surveys for every mission that are done using the orbiter boom sensor system. The one right after they get on orbit, I guess flight day 2, check out.
That's right.
And then one before they leave, which I guess they'll do on Monday.
That's
getting
right.
ready to come home, making sure that everything still looks good. They didn't get any damage during launch, and then they didn't get any damage, I guess, from micrometeoroid orbital debris
Those
hits.
are the 2 major sources of damage: is launch debris, falling off the external tank, particularly. There's so much thrust on liftoff that the vibrations are extreme, and it's impossible to keep everything on there. And if something does fall off in the first, I believe it's 2 minutes and 15 seconds, the shuttle is accelerating so rapidly, and they're low enough down that the atmosphere is so dense that the foam has a very large delta of velocity between the shuttle and its movement as it slows down, hitting this dense atmosphere. And that can actually create a damage in the shuttle, even though this foam is so light. So that's one of the major ways that the shuttle could be damaged. The other is like you said, a micrometeoroid impact during the mission. So, while they're up there floating around in space, there's little tiny particles flying around, and even, a little particle the size of a grain of sand can do some impact because it's moving so fast. So,
Now, in your system, is it used in both of those surveys, or is it something that would be used if they found something they wanted to look at?
Yes, it's we do turn it on and do a checkout during both of those surveys to make sure that we're operating normally and that the health of the system is fully up to par. But they don't use our system to do the full scan. They use our system when there's something that they really want to take a look at. So we're the detailed instrument. It's when they really need to make sure, that's when they come to us.
And they didn't have to do that this time, right?
That's correct. And most of the time, luckily, they don't have to use our system, and it's kind of a weird juxtaposition because we work very hard to design an excellent system, but that we hope they don't use it. It's kind of like we're designing an airbag or something.
And if they were going to use it, though, what would the image look like that they would get? Would it be something that we would recognize?
Yes, it would. You can look at we have software that we have developed that goes along with our system, and using that software, you can look at the image in a variety of ways. And one of the ways would be an intensity view, which would almost look like a black and white picture. The average eye just looking at it quickly would just think, oh, it's a black and white picture. But then with just a click of a mouse, we could switch to a different view, and suddenly you'd be looking at a 3D point cloud. This would be something that you could, click and move your hand around, move the mouse around the desktop, and this image would completely spin, and you'd be able to look behind it and in front of it, and you'd see the whole 3-dimensional surface. Using that image, we can then take very accurate measurements in terms of the width, the height, the depth, and therefore the volume of the damaged site.
How accurate are we talking?
We can see the width of a business card from several meters away.
Wow.
Yeah.
And that's important, huh?
It could be, yes. I mean, certainly, the TPS is one of the most important safety features of the shuttle. There's numerous safety features of the shuttle, but it's an important one. And any small damage could be significant if it was in the right location where, the understructure is particularly vulnerable or there's lots of heating on reentry.
Okay, so you actually come from Canada and you come down for each mission. Why
That's
is
right.
it necessary to come down for the missions?
Well, Neptec, the company I work for, the contractor, has an office down in Houston as well, and most of our operations staff works down here, but I'm one of the lucky Canadians that gets to come down. We need to have someone here during the entire duration of the flight, to monitor the system while the astronauts are actually using it and assist in any debugging if there's any issues or any problems. Also to monitor the health of the system throughout the mission and to constantly stay abreast of everything that's going on so that we're always ready right away to respond if there's an issue and they need to use us. In addition to the operations support, we also provide analysis of the data. And so occasionally I get to come down and work on that side of things, which is in a different room and kind of a different job here at Mission Control, but equally important in working on the data when it's downlinked.
How do you analyze it? Do you have models of how Discovery looked before it went up to compare it to, or?
Well, we do have some of those models. For the most part, it comes down to looking at the particular damage site, and we have various software tools we can use, such as simulating a flat plane surface and covering up the damage with that flat plane, and then taking a measurement of the lowest damage depth relative to that plane, and making calculations about what the volume would be if you filled it with water, for instance, or something like that. And we focus on the analysis of those measurements, and then as soon as we're done, we pass that information on, and then someone who's a TPS engineer, for instance, is going to make a decision about whether or not that piece of tile, how much is going to heat, and where it is, and all that kind of stuff.
Okay, so is this something that's just used for the space shuttle program, or are there other uses for it?
We are a company that's endeavoring to find spin-off technologies for this, and there are a vast array of other things that can be used for. In fact, other technologies, we have sensors that can be mounted to a helicopter to allow you to see through a sandstorm when you're landing, and it's a very similar system with a laser scanner that's used. It's modified slightly for that application. We also have automated rendezvous and docking sensors that we have one TRIDAR that's flown on the shuttle multiple times and will be flying again on STS-133. And we're very proud of all these sensors.
Well, now, is this something that you, I guess, knew going into your work that you were going to be working kind of on space applications, or something unexpected?
Certainly I was optimistic. I had the opportunity while I was still a student to work in the summer as an intern, so to speak, at Neptec for a couple summers. And back then it was when the space station assembly was still going full force, and Neptec was heavily involved with the space vision system. And I worked on the operations team, and while I didn't get a chance to come down here and actually support a mission, I worked with all the guys that did, and I even got to work with a few of the astronauts, like Steve McLean, who would come into our lab and practice using the system. And certainly it gave me a taste of what this world was like down here, and obviously made me really hope that I could get this opportunity once I graduated. And I was lucky enough to get that opportunity, so here I am.
And how many times have you been down here for missions?
This is my 8th mission. And so since I've been back with Neptec after having graduated, there's been 10. So I've only missed 2. I think that's pretty good percentage. Everyone up there is vying for the chance to come down. So.
Have you actually had any reason to do a focus inspection for any of the missions you've gone on?
Not any of the missions I've been on, which is a good thing. Like I said, I believe we've done 2 focus inspections since the LCS has been operable. And on one of them, STS-118, there was a fairly significant damage site. And certainly, the engineers here were concerned about it. And we went in and did a scan. And a couple of my colleagues, Ross Taylor and Peter Isles, I believe, did the analysis and passed that information on to TPS engineers. And they decided that that the damage was not significant enough to mandate a repair of any kind. And so STS-118 returned to Earth safely, and we were all very proud of that. And in that situation, we avoided having to, maybe schedule an unplanned spacewalk for the astronauts and send them out there without having trained for it to try to fix this. So, I think everyone at Neptec at the time was really pleased that we were able to contribute.
And will you be back for the remaining missions?
I certainly hope so. Things are always, busy with other projects up there, and everyone's vying for a chance to come down and support in the last 2 missions. But definitely, if I get the call, I'll be here.
All right. Well, thank you so much. We appreciate you coming out and telling us a little bit about this.
All right. Thank you, Brandy.
All right. This again was Ewan Reid, who works with the laser camera system on Space Shuttle Discovery's orbiter beam sensor system. And we'll go back now to live coverage on NASA TV. This is Mission Control Houston.